Hello, and welcome to our presentation for a new data analytics model for the Weight Watchers Corporation. My name is Christopher Olivieri. I will be presenting a new data analytics model along with my coworkers James Albergine and Christopher Yates. The overall objective of our analysis is to improve the company's overall marketing approach. Currently, advertising to the general public is conducted based on assumptions, specifically that the parties receiving the advertisement is in the appropriate weight class that the marketing department intends to market towards. The intention of our analysis will improve the way our company markets to potential customers by taking selected demographic data and applying statistical analysis to it. In other words, we are going to take past data to help predict a person's weight class. Our marketing department can then take this information and better target people that would be more willing to purchase a Weight Watchers program. The first step in our analysis was to do some research, both internal and external. The first type of internal analysis would need to be done by the marketing department. They'll need to take a look at their sales data, and they'll need to be able to determine which weight class of person is more willing to purchase a Weight Watchers product. That way, when we're done with our model, when we're better able to predict the weight of a person, they'll be able to take that information and then apply it. The second type of internal research that we'll need to do is essentially taking a look at our computing capabilities and our software. If we don't have the software that's needed in order to run this type of analysis, then we'll definitely need to go out and get it. The second type of research would be an external review, essentially. What we'll need to do for this would be to go out and get a base model of data in order to create the model on. What we needed for this was a lot of data, essentially, and we're going to need a lot of different characteristics, especially demographic characteristics and personal characteristics, in order to better predict, the habits of a person. After looking at a bunch of different options, we quickly came to the conclusion that the best type of data set that we would need would be the US Census data. It has a lot of rows of data and it has the characteristics that we're looking for. The US Census data was really an ideal data set for this type of research. It included many, many different attributes and characteristics. First of all, it had weight. So because it had weight, we are able to try to correlate, all the other different attributes to that. In addition to weight, it just had a lot of things. It had income, housing, how many children you have, all that sort of stuff. So we were able to take all those rows of data and, do analysis on it.
Because the file size we selected was so large, we were unable to import the data directly into Excel where we chose to manipulate it. We'd use various different programs to reduce the number of rows from almost 600,000 down to 50,000 and reduce the number of attributes to the ones that we felt were most relevant.
Data exploration. So in this portion of the data mining process, we initially looked at correlation and covariance, and the reason why is that we want to make sure that our data points are not going to be presenting the same information and then creating errors in the multiple linear regression model. We also did summary statistics as well as some charting associated to box plots and scatter charts and histograms in order to really get a good visual of any outliers or any data points that wouldn't be helpful in our data set to be able to predict the dependent variable. And then we looked at any areas where we can identify or pare down the specific attributes in order to kind of distill down the information. Data transformation is another important part of the data mining process. In this case, what you're trying to do is take the attributes or data points associated to a row and make them usable within your modeling and your method that you're choosing. First, we wanted to distill down from, we had over 250 different attributes available in our data set, down to the most relevant 13. We utilized an expert opinion to be able to do that, to get the most, the ones that we thought were the most appropriate to utilize within the model. Then we had to handle missing data by utilizing mode, mean, or a default value decided by an expert in order to replace that missing data, so that way we had data points for each one of the rows that we were working with. And then also transforming things from categorical values into n-1, meaning they're binary ones and zeros. And n-1s means 3 categories actually become 2 different rows, because if 2 of them are off, it means that the other one is on. So we were able to define that down and distill that down to be able to eliminate a lot of unnecessary attributes included into the model. So, why did we choose multiple linear regression? Well, initially when thinking about this topic and exploring the different data sets that we had available to us, as well as the business purpose behind it, we initially thought that we could utilize an ensemble approach to it, similar to what they utilize in the Netflix method to be able to predict what movies that you'd like. However, when it ended up coming when we started to run through those methodologies and test out those methodologies, ran into a number of different issues. So we looked at decision trees, we looked at kind of binning, neural nets, and multiple linear regression as possible functions to be able to better predict a person's weight as an outcome. So we'll go through a couple of different methods first, very shortly. Decision trees, when we ended up putting this together, there were so many different essentially nodes at the end that it wasn't really useful. It was interesting from an information standpoint, but not really necessarily useful from an ensemble standpoint. Although the decision trees and also multiple linear regression, I believe, is what they utilized in the Netflix kind of predictive model, where they were able to kind of create that average between the two. So we abandoned that because of the number of nodes and how expansive it was when it was actually doing the predictive capability associated to it in order to kind of bin those values. We also looked at neural nets. Neural nets was definitely an approach that was interesting. However, it did have its drawbacks. Neural nets was one of the more accurate runs that we've done when we tested out the model. However, we ran into a number of different issues. It didn't really give us very much insight. It would say, okay, these are the attributes, and this is what the outcome is, and it's going to tune itself to it, and it was pretty accurate. But at the end of the day, we had no idea how it got there. I mean, it was just waiting it itself out. That's the nature of a neural net process. So benefit was it was fairly accurate. Negative was we didn't really extrapolate. There was no surprise. It was just being able to predict out the weight associated to it. Whereas multiple linear regression allowed us to utilize a number of different explanatory variables in order to predict a dependent variable, where we were able to not only see what the actual outcome was, but we were able to see which attributes were the most correlated, or actually the best explainers of the, or the best predictors for the dependent variable. So not only were we able to obviously predict the weight of the row, meaning that we were able to predict the dependent variable that we wanted to in a pretty, we got some good lift out of it, meaning that we were able to predict it at a higher rate than being able to do it 50-50. But also we were able to identify attributes that we could utilize in order to tailor our marketing campaigns for our Weight Watchers campaign even further, such as we were talking about the ages of children. So people who had children between the ages of 6 and 17 were more likely to be at a higher weight when we looked at the data set, which was kind of interesting. So iterative results. So when looking at or building a model, so in this case we utilize multiple linear regression as our modeling kind of technique for the data mining. We get a number of values in order to base how effective our model is. So some of those kind of values are the p-value. You have your r squared, which is your error rate, essentially, r squared corrected, and you also have the coefficient, t-statistics, so on and so forth. What we did was we focused on a couple different values that we felt were really important to be able to tune the model a little bit better. So initially, like we were talking about before, we had narrowed it down to 13 attributes, but then we were able to, obviously through the data transformation process, we ended up with from 13 attributes really up to, I think it's about 25 total with the binary transformation of n minus 1. Then when you ran the initial model, we were able to identify the number of different data points, so attributes associated to each row, had a really high p-value, meaning that they didn't really help in predicting or in the predictive capability for it kind of explained the dependent variable to be able to tune the model any better. So when we're looking at it, things like school enrollment number 1, school enrollment number 2, means of transport to work 10, so on and so forth. A lot of these specific data points were really not helpful. And when we actually looked at them, so for example, a good explainer for this is means of transport number 10. I believe that off the top of my head is the trolley. So if somebody uses a trolley to get to work every day, it wasn't really a good explainer of a person's weight, or it doesn't help us determine a person's weight at the end of the day. So that's kind of an interesting thing. It could be a useful thing to understand a little bit better from a marketing perspective, but it also could be that there might not just be enough information. So we might have only had one row where somebody specifically took a trolley to work every day, so because it's not as common. Maybe it's only available as a streetcar in San Francisco or something along those lines. So after a number of different runs, we were able to kind of distill it down to a specific group of input variables, which were travel time to work, salary, hours worked per week, age, school enrollment number 3, which was if they were in grad school, I believe. Age of children 1, 2, 3, and 4, and that's whether they didn't have children, if they had children from 0 to 6, if they had children from 6 to 17, and then if they had children who were over the ages of 17. Those were actually really closely tied to a person's weight, which was kind of interesting. Divorced within the last 12 months, married within the last 12 months, whether they were. Marital status 1, 2, and 3. So whether they were married, not married, or it was not specified, or actually not specified, divorced. And then you have gender, whether it's male or female. Obviously, that's going to be a pretty good predictor of somebody's weight, or at least narrow down the range. And then health insurance, which was kind of an interesting thing that was correlated, or actually was a good explanatory variable, but wasn't really, the value wasn't really low in the p-value perspective. Which basically means that it was a good explainer, but not as good as some of these other kind of associated attributes for these rows. So again, we were looking at p-value, r squared, adjusted r squared, r root mean square error for the training, validation, and testing portion. Then on top of that, during the iterative results, we were able to utilize an extra set of data to score against our method. And we were actually able to see a pretty considerable lift. Right between the first 4 deciles, we were able to see a 1.2 lift right off the bat in our training set, and that carried directly through into our validation and also our test set, as well as our additional scoring. So the benefit was from the 2013 census, we were able to grab another set of data at our kind of given will, because we had a tremendous amount of data that we could pull out and then utilize. We were able to grab an additional set of data and then test against it in order to verify that we were able to get a lift in each one of the runs that we were able to run through the kind of model itself. Alright, so in the last portion of the iterative results, we kind of did try to utilize some ensembles, which we kind of talked about before in selection of method, which we abandoned, which was the decision trees in order to be able to create an average. That was actually part of our iterative results, but we actually excluded that out from our end final results. So it's not really described here. Thank you. So description of results. The project kind of resulted in not only use from a model in order to kind of predict the weight or the dependent variable that we were looking to predict, but also kind of received knowledge, which is kind of a surprise, in which we found out that a number of different explanatory variables were large contributing factors to predicting the dependent variable. Some of those are age of children, number 4, which was our data point number 4, age of children, which was that they had no children. So if somebody didn't have children, it was a pretty good predictor of their weight, which there was also a number of kind of age ranges where people had children between a specific age range did also dictate their weight as well. But it was usually on the outskirts, which was kind of interesting. Obviously, gender is going to be a pretty good predictor. If somebody is a male, they're going to be heavier than a female in most cases. And strangely enough, if they were married, is going to be a pretty good predictor of their actual weight as well. And then the last one was if they took a bus to work. So people who took a bus to work not necessarily means that they're heavier in weight, but it did give us a good perspective on being able to explain that dependent variable and be able to predict their weight associated to it. So by utilizing the p-value along with r squared, corrected r squared, mean squared error, so on and so forth, we were able to determine the attributes that were best explanatory variables associated to the dependent variable. We were then able to look at the root mean squared error as well as the r squared and corrected r squared to see how much of the the prediction was explained by the model, which was kind of a cool aspects associated to it. In these cases, with these type of models, when you're talking about human choice, and obviously weight and whether they use a bus to work or whether they're married or not or something along those lines, psychological factors with humans, usually you don't get a tremendous lift, but we were actually able to see a fairly consistent lift across all of the different models, which was a huge benefit. So in conclusion, kind of associated to that with the final results, we were able to deliver not only a number of different attributes to be able to utilize in defining the actual marketing campaign, saying we're going to focus on people who either have children or don't have children. We'll be able to define that right off the bat. We're going to be able to define if we're going to go after married people, if people who frequent a bus or a trolley in order to get to work. And we're going to be able to do that. Not only that, but we're also going to be able to identify which people would actually be in our weight range that we're looking to approach. And that doesn't necessarily mean that the marketing campaign is going to say we want everybody over the weight of 300 pounds. It could be we're looking for people within the weight ranges of 125 pounds to 170 pounds who are a specific gender. It doesn't really matter because they could be looking at which areas are most profitable, and sometimes specific groups of people, specific demographics might be more profitable to Weight Watchers as a whole, and they're going to be able to identify this regardless of whatever the cutoff is. So that is our final results, and to go into a little bit more detail, you can also see the attached final report that's associated to this PowerPoint presentation.
Upon completion of this model, the findings will be passed along to the marketing department, who will use this information to gain a better understanding of the market that they're looking to target. By knowing the attributes that are most correlated to weight, they'll be able to more effectively and efficiently market to this grouping, reducing the time and cost required to market towards them. We hope you have enjoyed this presentation. For more information, please view our final report. Until next time, farewell.